All right, obviously this is the video for 3.9, absolute value equations and inequalities. And again, just like the last section, apologies because a lot of this writing I'm going to be doing like literally with my mouse and hand, so could be a little sloppy, but here we go. And keep in mind, just to kind of, let this title sink in, we're going to be dealing with not just inequalities, like this whole chapter. Actually, wait, I take that back. Lately in the chapter, it's been about inequalities so far, but it started off with equations, and then we were doing some inequality stuff. Now this section includes both, and all involved with absolute value. So hopefully you're going to remember what absolute value means. But so here we go. Let's start with absolute value equations, which this is as basic as I could probably get. Just where it's the absolute value of x equals something like 5, right? So it's the absolute value of x. And again, we want to solve this. We want to know what solutions, or if there's only one solution, more than one solution, no solutions, I don't know. But what could replace the x to make this true? And yeah, I just kind of was just talking about, remember what a solution is, or what it means to be a solution, what the word solution means, or what a solution is, like in like by definition. So here, well, that was maybe a little premature, but I guess I wasn't expecting that so quickly here. But yeah, so think about it. There's two solutions here. If x was 5, that would make it all work, because the absolute value of 5 equals 5. But you could also have x be negative 5, and this is true. The absolute value of negative 5 equals 5. So yeah, that's kind of what is going to be happening here in this section. That's like your first taste of how this is gonna go. So it's like we're going to have a positive case for our variable, but also like a negative case, so to speak. Don't take that literally, or don't make any assumptions about that just yet. Let's see how this plays out. So can you list the solutions to this? Like, what if we make it a little more complicated? See, now it's the absolute value of 2x minus 4 equals 12. Okay, so still kind of explaining what's going on behind the scenes with this example maybe. In order for the equation to be true, right, this quantity of 2x minus 4, this whole thing in the absolute value, this whole 2x minus 4 needs to be what? Wouldn't this entire 2x minus 4 need to, in its entirety, be like a positive 12 in disguise? Or it could also be a negative 12 in disguise, like this whole thing. If this entire 2x minus 4 was really just negative 12, it would be, this whole thing would work and it'd be true. Or it could be, this whole thing could be a positive 12 and it would work out. So this is what you literally write down. Okay, so here's going to be the routine. We can drop the absolute value, okay, and just set this 2x minus 4 equal to positive 12 or negative 12. Like, those are the two different ways for this to work. Okay, and then once you write that down, like your two cases, absolute value, as Mr. Birchanowski says, has two of these little vertical lines, these two lines to make absolute value. So if there's two lines, there's two cases. And yeah, positive case, negative case. And then all you do from here is, like, now you can solve for x. What would x have to be for all of this to be positive 12? Well, we add 4 to both sides, then divide both sides by 2. You get an same thing over here. Add 4 to both sides, and then divide both sides by 2. You get a negative 4. So there's two answers here. X could equal 8, or, and it is technically the word or that's needed here, or X could be -4 instead for this to work and to be a solution. Okay? And maybe I'll say this because it just popped into my head and I don't want to forget to say it later. Might be a good time anyway to say this right now. Look, there were two cases, there were two answers. A lot of people misread that and they misplay this in like execution where, oh, so they get an answer of 8 and then they just say, oh, is the other answer -8 then? No, that's not always true. So that's a mistake that people make a lot. You know, they get an answer of 8 and then they go like, oh, there's a negative answer too. So we'll just say the other answer is -8. Guys, the answers, your two answers, they're not even always one positive, one negative. Okay, so just, right, make sure you're aware of how this plays out in order. You set it equal to a positive 12, and then you also set that equal to a negative 12, and then whatever you get from each case, you get. Here we got positive 8 or -4. This next example, look, this adds a little wrinkle because does this equate, like, can we say like, oh, so 4x minus 1 would basically equal 10, or it could be a -10 in disguise. Is that what you can kind of, you know, dissect? No. So here's what you do. So add this to like your knowledge base here. Before we break something up into two cases, the absolute value has to be isolated. So here it was already isolated. There was nothing else over here on the left side. But here, you know, so that's going to be part of the procedure. You know, step 1 is could be isolate the absolute value part if necessary, and it's very necessary here. So the first thing we're going to do is add 5. We're going to get that out of there. Jeez, I don't know. This is sloppy enough even in advance. I should have just wrote this with my mouse. But we get to here, right? Is the absolute value part by itself yet? No. So we're going to divide both sides by 3, and that'll cancel out the 3. Okay. And now that it's isolated, now we can break it up into the two cases. So this 4x minus 1 can be set equal to 5 or -5. So again, we drop the absolute value and then we write the two cases. Okay. And I was just saying that. So step 1 is going to be to isolate the absolute value part or get the absolute value part alone first. Then we can split into the two cases. And it looks like our two solutions, when we add 1 to both sides and then divide both sides by 4 for both of these, you'd get 1.5 or, you know, 3 halves, 3 over 2, or -1. So here we go. Moving on. Let's see. So we have an absolute value equation. Is there any isolating we need to do? Like, is the absolute value part already by itself? Actually, yeah. So we could go right into the two cases where this 2p plus 5 would be set equal to positive 11 or -11. Solve, 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 boom, bam. Okay? In hindsight, that might have been one you could have tried on your own before just writing this down, but oh well. Number 2, right? So number 2, all right, listen. Is like at this point in time in your education on this, right? You're looking at that, and I guess what should you be thinking? You should be thinking, well, I mean, the absolute value is isolated, so we could break this up into the two cases where we have it equal to like 7, and then for the other case, we change the 7 to a -7, but this is, wait a minute, this is already a -7. Is that normal? Because look, here it was like, well, here's the first case, positive 11, and then we make it negative for the other case, which is what happened also here and also here. So is it weird that it's already a negative 7 over here? Because, well, yeah, it is, you know? So listen, people, the norm is that the number over here on the other side is positive. And then you make it negative for the second case. And just think of this overall. The absolute value of what? Like, what would this x plus 3, if you thought of this just from the original approach, right? The absolute value of what? Like, what would this entire x plus 3 need to be in disguise? Like, it'd be what in disguise? The absolute value of what equals negative 7. Wait a minute. Is the absolute value of something ever negative? Well, guess what? No. So for number 2, this is the kind of thing where there's no solution. You know, if the number over here is already negative, that's weird. And if you think about it, impossible, right? The absolute value of, like, what would be in here? Like, what would you say? It's like x plus 3 could be 7? Like, no, the absolute value of 7 is not negative 7. The absolute value of nothing is negative 7. So, all right, moving on to inequalities, the other part of this shindig. All right, here we go. So what if we had absolute value involved in an inequality? Think about it. What number or numbers would make sense in here for x? The absolute value of what would be less than 5? Well, I mean, the absolute value of 4 is less than 5, right? The absolute value of 1, the absolute value of 0, what else? Any negatives? Would any negative numbers work in here? Yeah. Negative 1, negative 2, negative 3, you know? In other words, let's cut to the chase. Anything that's less than 5 and at the same time, what? Greater than negative 5? In other words, everything that's in between negative 5 and positive 5, right? So this is going to, so speaking of two cases, absolute value, 2 lines, 2 cases, this right here is our 2 cases. So here's going to be the procedure. Just like before, just like with the equations, we're going to make sure that this is isolated, you know, like if the absolute value part is all by itself, okay, we can break it up into the 2 cases, where in case number 1, it's just like as is, less than or equal to, or whatever the symbol is, and then the positive 5. So again, this has to be positive for it to be normal at first, okay? And then the other case is going to be 2x minus 1, again, but we're going to not only make the 5 negative, but we're also going to make another change in case number 2. We're going to flip the symbol. We're going to flip the inequality to a greater than or equal to. And the word is and. Sorry, it's like sloppy handwriting. Okay? And then after that, you just solve each one of them and make your graph. Let's see how it works out all the way through for this one. Is the absolute value already isolated? Yep. So 3x plus 2, here's the first case, just as is. Drop the absolute value, and that's the first case, just less than 8. And again, the word is going to be and for less than. And the other case, 3x plus 2, that doesn't change. But what does change is it's now going to be greater than negative 8. Okay? Now we're going to solve each one of these and make the graph. And look, the word is and. So I'm betting that it's going to be like an in-between type graph. It's a pretty good bet. Divide both sides by 3. So we got x is less than 2. Same thing. Subtract 2. Negative 8 minus 2 is negative 10. So then we divide both sides by 3, and we get x is greater than negative 10 thirds, which is about negative 3 and a third. So that would be like, you know, right there-ish or something. But we're greater than that, and at the same time, yeah, this is going to be like an in-between thing. Shocker. So what happens with, what if it's a greater than? So what's the basic situation for greater than? What numbers, right? Well, the absolute value of what is greater than 3? We're probably thinking like 4, 5, 6, 7. But don't forget about negative 4, negative 5, because the absolute value of negative 4 is 4. So anyway, watch what happens. If you break this up into two cases, yeah, right? It's all the x's that are greater than 3, you know. But the other ones would be less. See, we flip the symbol, make the 3 negative. But here, would the word that connects them, would it make sense to be and? You know? Does it have to be greater than 3 and less than negative 3? No, the word would be or. Think about it. The solutions to this would be, you know, anything that's greater than 3 or less than negative 3. So again, that's good news. That with absolute value, it's just going to be like the same kind of approach where as long as the absolute value part is isolated, like there's nothing we have to move to the other side, we can go right into the two cases where, again, the first case is pretty much as is. We're dropping the absolute value, but the first case is just as is. And with a greater than, the word that technically fits in between is or. And again, just like before, the other case is going to be the 2x minus 4, but then not only is it going to be now a negative 2, but that is going to be flipped. Okay? And then here, I wonder how much room you guys had to do this, but let's see, we're going to be adding 4 to the other side, and then dividing both sides by 2. Same thing over here, adding 4 to the other side, and then dividing both sides by 2 to get that. And again, remember the word's or. So I don't think there's a number line here in our handout, but if you were to graph this, think about it, greater than or equal to 3, or less than or equal to 1, totally looks like a typical or graph. 2 oars in the water, baby. Okay, here we go. Is there anything else? Any other wrinkles that could pop up or any other plot twists? Let's see. Quick check number 3 on whatever textbook this is from. Check it out. So the absolute number, so let's see. Again, positive 3, that's everything's working out. So we can make our two cases, right? Just greater than 3, but the other one would be, what are the changes? Flip the symbol, make that number negative. So W is greater than 1. W is less than negative 5. And when we subtract 2 over, and again, what word makes sense when it's more than? So there's going to be a trick. I don't know if we're going to write it down somewhere, but if it's a less than, it's and. So it's kind of like a sort of a rhyming sort of phrase. less than and, more than or. Less than and more than or. Helps you remember. So this is technically an or, so I wonder what the graph's going to look like. Greater than 1, less than, oh, what do you know? The graphs are running away from each other. I'm shocked. These last two in the notes, maybe you're noticing right away, like, wait a minute, when I go to make my two cases, this is already negative. Like, I'm not going to be able to turn it negative for my second case. It's already negative. Is that weird? Yep, it's weird. Just like before, it's weird. So this should not already be negative. So let's think about what this means. When is the absolute value of something? Well, let's go back here just for comparison. When is the absolute value of anything, whether this was just an x, or an x plus 3, or a 5x minus 7, doesn't matter. Like, when is the absolute value of anything equal to something negative? Well, never. We already talked about that. But when is the absolute value of something greater than, say, -3? Always. So you could say always true. And if you were going to, like, graph it, it'd be like the entire stinking number line. Think about it. Does that make sense? When is the absolute value of anything, whether it's just a w or an x or w plus 2 or whatever, isn't the absolute value of something literally always going to be greater than negative anything? But conversely here, when is the absolute value of something going to be less than something negative? Well, never. You know, or you can say no solution at all. Okay? So keep those special cases in mind as well with these absolute value inequalities, and I guess that's it.